as well. So yeah, we'll get Richard to take us through that soil pit sort of protocol and assessment and how we might go about it. And then as more people join, we'll talk about the wrapping up of this project and I guess, yeah, just mentioning that there'll be an end of project survey as there are for National Land Care Program projects. You guys did a baseline survey to start with, so we'll just do the final survey. And I'll also talk about there could be an opportunity. We are negotiating with the National Land Care Program at the moment for the possible extension of this project. So there were some funds left over, so because we didn't get to travel and that sort of thing. So we are negotiating that opportunity of running it out for another, well, it won't be quite 2 years, but 22 months or 20 months or whatever the time frame might be. And either expanding the giving you guys the opportunity to continue in whatever capacity you might like, and then bringing in some more participants or additional participants to be a part of it if they want to. So still trying to keep a similar number of participants so that we can have a good group discussion and those sort of things. And also, yeah, so giving you the opportunity to continue if you like, and bringing in new people. So, but I can expand on that, and if you want to think about that or have some questions, then we can go on to those. But so perhaps Richard, yeah, would you like to kick off? I guess I just thought, yeah, if we could go through that sort of soil pit process, and I'll if you've got some resources, then we can share it with the rest of the group. But I'll also put something up on the Extension Oz platform in regards to this topic. And I was also wondering about, and I alluded to it in the email, but also about sort of accessing information about soil pits that have perhaps already been dug. And I think Richard Harper mentioned it a little bit, but I just wondered, yeah, does WA have a soil database or soil other than soilquality.org? Is there anything else, a GIS sort of database?
Well, there's the couple of things. One is DPIRD has quite a lot of publications at sort of different levels and different different geographic areas. So always find that they've got a wealth of information if you just dig around there so it might be describing soil types or soil groups and generalized properties or more specific like soil survey type documents for particular areas. That's one. I don't know if you're all aware, but CSIRO, if you've got an iPad, you can access through CSIRO, I think it's called Soil Map. So if there's a soil profile with a description near you, you can call that up on the that app and look at the details. And the advantage of that is that it's, it can be location specific so that you're getting information that's most closely related to where you are and the type of soils that you're dealing with. Because I presume that all of the project officers, Peter perhaps covers a bigger area, but most of you have quite, well-defined areas where your members are located, and it's important to know those soils rather than necessarily the soils from other parts of the state. And then, of course, Soil Quality, the ebook, is a good starting point as well. Now, Felicity, I thought we might start with a little video from there.
Yep.
If I can share that. So can you see that?
Yes.
And so this is in volume 1, book number 1, and can't see the actual page number there, but there are 3 videos describing 3 different soil types. And the one that I found was probably most useful at this stage is the one I'm going to click on.
Okay, we're in a typical sandplain landscape for the South Stirling's region of Western Australia. We're here looking at a gravelly soil. So as a gravelly soil, you'll find this anywhere from Geraldton down to Albany, across to Esperance, and also in some parts in the countryside out towards Merredin. As you get across towards Esperance, you tend to find that there's less clay in this topsoil section and subsurface section through here. And really all I'm doing here is just demonstrating where the layers are. Is all you're really just looking at is where the layers change either in colour or in texture. So in this instance, for example, I can see that this is a sandy gravel that sits over the top of a clay. That's fairly straightforward. So we'll just do the first layer that I can see, which is quite easy there. There's a fair proportion of gravel in the profile. Next one, it's about through there. And we have this quite large chunk of clay that changes down to about 100 centimetres. So one of the things about gravelly soils is that they do present more physical constraints for production. The gravels can be quite tough. This particular profile, because it's got a little bit more clay through the profile, can also be quite compact at depth. Although as we've gone down through the profile, we can actually see that the bottom clay is quite friable. As you break it open, it breaks quite easily. And where it breaks easily, these are where roots will penetrate into the soil. The topsoil is water repellent. It's quite water repellent. Water repellence is where the water beads like a ball of water, literally, and doesn't penetrate into the soil. When you look into the subsurface in the second layer down, which is about 20 to 40 centimetres or so, 10 to 40 centimetres, you can actually see that there's quite a fine matrix of soil around the gravelly pieces, gravelly rocks that are in there. One of the things about these soils is that because of the fine matrix of the gravel, and also on some of these gravelly rocks that are in the profile, if they've got a porous outside, they can actually have quite a high water holding or water retention availability of water, but they can also hold well onto nutrients. One of the things with this profile, as you look through it, it does actually have a lot of already roots that have managed to penetrate through the profile. Down here, there's actually quite a mass bundle of fine roots that have penetrated down to a metre 10. And it's quite a good sign to be able to see in the soil that roots have made it that distance. A feature of the profile in this particular instance is the presence of old bush roots, remnant vegetation. Here we have the bolus of the root. There's some other roots that probably go around it. But in this instance, it does add some biology and some preferred pathways for drainage and nutrients and other roots to follow. And this bush root actually penetrates all the way down to about a metre 10. So that's quite a fair penetration. And you'll find, and you can probably see it, that other roots have actually gone alongside this root. So again, existing roots that are in the profile present an opportunity for roots to follow alongside and also for biological development. A common thing that a lot of farmers like to do on these gravelly soils, because of the compaction layer, is to deep rip them. Deep ripping can be a win-lose situation. Sometimes if it's already got existing remnant roots through there, there's a whole microcosm of biology that's going down through the profile. In a lot of respects, you don't really want to disturb that. But if that's not present, and it's definitely a compacted soil, and it's not a sodic soil, and it's deep enough, sometimes ripping can be quite beneficial for these soils. The other thing of interest is looking at different faces in this soil pit. This second clay layer, you can actually see that the clay surface is quite wavy. When you get that wavy surface, it's a good surrogate or a good indicator to say that the soil is sodic, and so that's a high exchangeable sodium percentage. The issue there, of course, is you get dispersion in your clay. The clay will slump. Often in a waterlogged situation, the surface of that clay will seal, and that presents a whole set of other issues. The two most beneficial measurements are pH and salinity. And I don't envisage salinity to be an issue on this soil because it's high in the landscape. It's a relatively well-leached profile. But the best way of being able to determine the pH is to use a universal soil pH indicator, which we just essentially spray on the profile. The significance of pH in a profile, if it gets down to more your orangey type sort of colours, and where there's a little bit of clay in the profile, you tend to get aluminium that becomes dissolved moving through the profile. Aluminium in soil is a bit of an issue, particularly causing aluminium toxicity. In this soil, I don't imagine it to be too much of a problem, but it's something to still watch out for.
Okay, I just thought that was a nice little relatively short video of the soil profile description process. Look, it would have been much better if we were all out in the field, able to see profiles for ourselves and get our hands dirty and learn some of the physical methods that Tim talked about. But there are broadly two ways in which we describe soil profiles. There's the process that pedologists use, which is quite elaborate and very detailed, and it's primarily around soil classification, fitting the profile to a particular classification system so that we can give it a name and be able to refer to it when it comes to publications. However, for most of us, our need is much more pragmatic than that. More of the style that Tim used in that presentation there, where there's perhaps half a dozen or a dozen characteristics of the profile that are going to be important for plant growth and for agricultural production. And so we would normally focus on those. So we're looking at properties rather than necessarily having a classification or a scientific name for the soil. So just wanted to perhaps use that as an introduction. And I'm not a pedologist. I guess my interest in soils is much more the pragmatic approach of looking at those soil properties that are going to be significant for plant growth. So I've got some slides here, which I was going to just go through. So the photographs show a soil judging competition. Soil Science Australia, which is the professional body for soil scientists, normally holds annual soil judging competitions, and they gather teams, usually of students, undergraduate students, and they'd normally spend a day or a couple of days with a tutor learning the process, and then they would front up and be given a soil profile and have to describe it in a fixed period of time, and then they get judged according to who got the best classification. So this is one that we did at the Whitby farm. Remember, we were going to go to Whitby farm and look at some of these profiles, but we didn't quite make it. Places where you can find more information are listed here. The yellow book, the Australian Soil and Land Survey Field Handbook, is really the standard methodology that is recommended in Australia for describing soil profiles, particularly if you're a pedologist and doing soil survey. if you're doing soil surveys, there's also the CSIRO publication led by Neil Mackenzie of CSIRO. All of this formal classification refers back to the Australian soil classification, which has just been updated. It was released about a month ago at the National Soils Conference, the 3rd edition of the Australian soil classification. But what we're going to focus on here is the simple guide for describing soils that DPIRD has put together, which I think is more the level of information that is appropriate for this group. It's the level at which I tend to focus soil profile descriptions, and it's focusing on those properties of soils that are going to have significance for plants, crops, and the agricultural context. So there are different ways in which we can collect information about soil profiles. We can dig a pit, we can look for natural sections, or we can use an auger, and they have their advantages and disadvantages. And once we've got a soil profile, we rely a lot on morphological properties and field properties and describe those. If we use standardized terminology, that helps. It helps to standardize and clarify the communication between people, so that we minimize the misunderstandings. So if I'm talking about a red soil, are you visualizing something that's red, or is my description not very accurate and it's really more of a orangey brown color, and we're not accurately communicating with one another? So if we use some standardized methodology and terminology to describe properties, then we've got the basis for a scientific evaluation of soils and to be able to communicate information about crop management and crop production and alleviating soil constraints and the like. So with augers, you can auger soils using back of the truck type devices, such as shown here, or you can use a handheld auger. This particular auger is quite a good one because it collects a section intact with a reasonable diameter, so you can see the whole profile and get a good idea of the material. The hand augers are only going to collect a much smaller amount of volume of soil, and in the process of collecting it, you generally disturb the soil to some extent. So there are some properties that you can assess with an auger and some that are not so reliable. If you can find natural sections, that can be a really good way of looking at soil profiles. So this is one that we take our Water and Earth students to each year out at Westdale, and the Department of Agriculture put us onto this site. It's actually a drain that was dug here to drain this wet valley land, but it's quite a nice sequence for us to take the students because we don't have to dig the hole, and we can see a long section of the soil, whereas a pit or an auger gives you only quite a narrow section of the soil, and you might be missing some of the variation in soil properties. You can find other natural sections along road cuttings, railway cuttings, quarries, such as shown in this particular image here, and they can be quite useful as well. But of course, these sections are sampled opportunistically, and they don't necessarily cover the whole landscape or the parts of the landscape that you're especially interested in. or you can dig really big holes. This is Richard Harper in his younger days, being very heroic, but actually we should put a big red cross across that photograph, because nowadays you're not allowed to dig holes like that. It's just a safety hazard, particularly on the sand. With that depth, the material could collapse, and with tragic consequences. So there is actually an Australian Code of Practice for excavation, which says you shouldn't dig a section more than 1.5 meters deep in order to avoid risk to human safety. But you don't even need to go to 1.5 meters often. And deep herds have been really good at developing a methodology based on backhoe pits, where if you've got a particular soil type or soil constraint, you can gather a bunch of farmers, advisors, get a backhoe and dig out a pit like this, which is only about 70 centimeters deep, and then go through a specific methodology that focuses on colour, and in particular, what are the horizons, what's their thickness. You might look at the boundary, whether it's flat or wavy, as Tim mentioned in the video. You'd look at evidence of waterlogging, that is water in the profile when you dig the pit, or mottling, variation in colour, which might indicate annual waterlogging in the profile. You'd look at soil water storage, so just which parts of the profile are dry and which parts are wet at that particular time of year. If you dig these pits in the late spring and you find topsoil is dry, or even it's dry down to 20 or 30 centimeters, and then there's plenty of moisture deeper down, but the crop is drying off or showing signs of moisture stress, that's a very good indication that there might be a subsoil constraint, which is stopping the roots from accessing that water. And that might be pH or hardness, compaction. So the presence of roots can be a really important indicator of these profiles, because the roots won't go where there are significant constraints, and that can be a good diagnostic. And of course, at the surface, water repellents can be measured quite simply. Just need to make sure you take some good quality water out. So not hard water, quite fresh water, and you can check water repellents just with that water beading response, as Tim showed in the video. And for pH, not sure where you get the universal indicator from, but you could certainly check with DPIRD, people like Tim Overhue or Chris Gazy or Steve Davies. All of those guys are really very adept, very good at doing this sort of backhoe pit diagnosis. And the guy in the photograph in the blue parka is Jeremy Lemon, who was also really very expert in this, because he had a very long familiarity with soils of the south coast of Western Australia. Jeremy retired at the end of last year, but if you're looking for somebody who could take you through that process with growers, you could do much worse than trying to get hold of Jeremy and see if he'd be prepared to come out and take you through that process. Soils are extremely variable, and Richard Harper in his presentation talked about landscapes and some of the driving factors for variation in soils. There's the 5 external soil forming factors that explain most of the variation in soil types. So the parent material or rock, it doesn't have to be a rock, it could be a sediment such as an alluvial sediment or a windblown sediment. But this is the basic material from which the soil is forming. The formation process varies with relief, so elevation and slope, which have a big influence on rates of erosion and hydrology, the moisture environment for soil profiles, the climate, the biology, and we're learning, for example, that some of the native marsupials, woylies, bettongs, they were actually very, very active burrowers and disturbers of soil in natural ecosystems that we now think probably had quite a significant influence on the formation of our soils under natural vegetation. And of course, time. The longer you've got, the more sophisticated the soil profile can be, particularly if there's no erosion. And in parts of Southwest Australia, the depth of weathering goes down to 70 metres. And the weathering has been going on for hundreds of millions of years. So you can have quite a sophisticated soil profile that might have experienced many different cycles of climate. Cycles of climate unlike the present day climate. But within a landscape such as this, differences in elevation, slope, parent material, all will be correlated with differences in soils. And so for your particular environment, you will build up a knowledge of what the association between soils and those landscape features is. Soil horizons are the essence of describing the differences between soils, and over time, with weathering and leaching, depending on the amount of erosion, we can start off with a parent rock or a parent material that becomes increasingly differentiated into so-called layers or horizons. And pedologists have a way of describing those or naming those horizons. I think for most land managers and the type of work that I do and probably most of you do, we don't really need to know all of the naming conventions for those layers. To describe the soil profile based on morphology and properties we can describe in the soil, there are various properties that we focus on, and there are other properties that pedologists would assess, which we don't need to worry about, and they're listed at the bottom. So describing the horizons and the boundaries and what the depths of the upper and lower depths of those horizons, as Tim showed, the overall depth of the profile that restricts root growth, such as cemented pans or rocks, the colours of the different layers and whether the colours are uniform or mottled, the texture, the presence of coarse fragments, the structure of the soil, what's the water status, what's the condition of the surface, so is it loose or hard setting, compacted, water repellents, segregations, whether there's any free carbonate in the profile, which would indicate alkalinity. We can measure the pH in the field and electrical conductivity. And as I said, knowing where the roots are, and in particular where the roots aren't, is a big part of understanding the soil profile. So just going through some of those properties, the standard way in which we measure colour is through a Munsell soil colour chart. And I'm sure you've all been to Bunnings and got those little colour charts. Well, for soil, we have a particular selection or combination of soil colours, because of course in soils we tend to get more of the yellow and red and grey and brown colours, and not so many of the other sorts of colours. And the Munsell soil colour chart, they're not cheap. I think they're currently $350 to $450 to get one. And they're arranged into charts which have a spectral colour called a hue. And then these rectangles are arranged according to their lightness or darkness. So dark at the bottom and light at the top. And according to the chroma or the intensity of colour, where on the left is grey shades and becoming more intense as you go to the right. Soil colours will vary a little bit with time of the day and also whether it's a dry soil or a moist soil. And that's what the book looks like. And what you're doing is a matching. So you're simply taking a sample of the soil, putting it underneath the chart where there are holes, and then trying to find the best match. So once you've found the right match, you then look on the left-hand side and it gives the standardized color name. So this chart is 5YR. Where the arrow is pointing is 5YR 5/2. And so if we look on the left side, the formal name for that is reddish grey. However, you don't need to be quite as detailed as that for most soil constraint analysis, which is of interest to land managers. Broadly, we're looking at whether the soil is red, brown, yellow, grey, or black in colour. And if you can differentiate it into those 5 groups, then that will often be enough for the purposes that you have. Different horizons within the profile might have either very uniform colours or mixed variegated colours that we refer to as mottling. And the most common type of mottling is a rusty reddish brown coloration. And that can be indicative of differences between soils, and it can be indicative of waterlogging in the profile. And we can describe the mottling in terms of the abundance. We can actually use the colour chart to describe the colour and size and the contrast and the boundaries. But for most of us, we just would like to know the colour and the abundance of the mottles. And the Munsell soil colour chart's actually got some extra charts which help us to visually estimate what the abundance is. So just looking at the mottling, we try and match it up with these different quarters and come to the closest approximation of how much mottling occurs. Of course, there can't be more than 50% mottling, because if it's more than 50%, it becomes the dominant colour. Another property is what we call segregations. And at first, these might look like mottles because they do present different colours. But mottles are soft soil material and segregations are hard, as shown here with these gravel fragments, which are obviously quite common in our West Australian soils. And there's quite a discrete boundary between the hard segregation and the soft soil material between the segregations. We can differentiate those segregations and fragments according to size. So there's a formal size class for different gravels and boulders. Similar to segregations are what are called coarse fragments. The difference between them is a coarse fragment refers to part of the parent rock that hasn't yet weathered. So in granite-based soils, you might find coarse fragments of quartz. So that's from the parent rock, not yet weathered, whereas the segregations are materials that form through the weathering in the soil, and they might be ferruginous, that is iron-rich, or calcareous, that is alkaline carbonate materials, or manganiferous. And we can describe them in terms of their colour, their abundance, and their size. So here's a gravelly soil where most of the soil material is gravel and there's relatively little fine material. Another of the physical properties is the texture. And texture we divide into 4 size classes, or really 3: clay, silt, and sand. And we do the texture assessment after removing all of this coarse materials. So anything that's more than 2 millimeters diameter, we take out of the sample, and on the remainder, we determine the percentage of clay, silt, and sand. And we may have reason to differentiate the sand into coarse and fine components. In the DPIRD book on describing soil profiles, it gives you a methodology for hand texturing. So this can be done in the field. And that's sufficient with a bit of experience to give you a pretty good indication of what the texture is, based on the formation of a bolus, whether it will ball up when it's wet, as shown in the 3rd photograph from the top, and whether it will form a hanging ribbon when squeezed out between your thumb and finger. The length of that ribbon is determined by the organic matter and particularly the clay content. So that ribbon, the length of that ribbon, as shown in this next slide, can be used as an indicator of the amount of clay and therefore the texture class in the soil. Other properties, pans. So this is any horizontal layer within the profile that is strongly cemented together, which would inhibit root growth or water movement through it. And there are a variety of different compositions of pans. Soil structure or pedality is another of the physical properties. Sand, grains, clay, organic matter, and cations like calcium can combine together to create a secondary particle that we call a PED, or an aggregate. And that is shown in the photograph on the right-hand side, where with some soils, if you take a handful of the soil, particularly from topsoil, and then just gently apply a bit of pressure, it will tend to fracture and break up into these PEDs, as shown on the photograph on the right there. And in terms of soil structure description, we can describe how much of the soil mass is in the PEDs. Note that sandy soils are apedal often. They don't form PEDs. You just find single grains of sand. And many of our hard-setting clay-rich soils also have no PEDs, so they're massive apedal in their structure. So we can describe whether the soil is pedal or apedal, then how well developed the PEDs are, and we can describe their size. So that's what's called a granular type structure. And the best way to look at structure is in the field using a pit or a section. Often if you use an auger, it mashes up the soil and you can't accurately assess the structure. And one of the ways in which you're going to see whether there is structure or not is looking at the way in which the soil cracks. And so you can see in this profile at the surface, there are some cracking patterns, and then there's a layer where there's very little cracking. And then below that, you get this blocky sort of cracking pattern, which indicates a different form of soil structure. And pedologists have different shapes that they've defined that are used to describe the type of structure. Other properties, pH. You can use that method that DPIRD uses with the spray bottle, but I think the pH test kit, which you can buy from Bunnings, is pretty good. Certainly sufficient to pick out the very acid, the very alkaline, and the in-between soils. Mentioned you should look for the roots where they are, and also look at the boundaries between horizons. That can be informative. So I think Felicity sent out this simple guide for describing soils that DPIRD put together. So, they have suggested a pro forma for describing the soil profile, just the basic information that is likely to be most important for interpreting the properties. So in addition to each layer and describing upper and lower depths, texture, boundaries, soil water, fragments, colour, mottles, pH, EC, whether there's calcareous material, the structure, and anything else that you think is significant. You do that layer by layer, but also recording some properties of the landscape, where it occurs. Is it on a hilltop? Is it in a depression? Is it on a slope? What's the nature of the surface? Is there water repellence? Can you identify the parent rock or the parent material? And so in a profile such as the one shown in the bottom right, there are clearly, there's a horizon, which is dark coloured, but you can divide that into two layers. There's a shallow surface part of that, which is a little bit darker than underneath. And then there's quite a sharp transition into the more brownish, orangey brownish colour. But even within that layer, there seems to be a place about halfway down where there's a lot more gravel that might denote a different horizon. So even from this distance and not being able to get up close and have a really good look at it, there's probably 4 different horizons there that you could recognize. And the other thing which we'd normally do nowadays is record location with a GPS. In terms of soil profiles, if we're interested in defining the soil type, we would normally describe it by horizons. But when it comes to plant growth and fertility, we normally describe it or sample it by depths. So anyway, that's a quick overview of soil profiles. I'll stop sharing there. And I notice there's quite a lot of comments in the chat, which I haven't been following. So presumably those are the questions that people might have that in the time remaining, I guess we would focus on that. Yeah.
Yeah, that's okay. Thanks, Richard. I've just been actually popping a few comments as you've been talking. Just picking up on a few pertinent bits that you've said. So I can't actually see any questions in
Okay.
there. But if anyone has got some questions, feel free to unmute yourself and or pop it in the chat. If you Peter did ask, and I'll just check with you, Richard, though, that the Bunnings pH soil test, that's in water, isn't it? The
Yes.
I think they just do the calcium chloride at the lab. I mean, they do water and calcium chloride at the lab, but if you want calcium chloride, you have to send it to the lab.
That's a really good point. That and actually, I got caught out myself on that once with a group of students. That you often, in fact, nowadays from the lab, we recommend calcium chloride pH as the standard. You can still get a water pH, but if you're going to compare it with the test kit, you should be comparing with the water pH, not with the calcium chloride pH.
Yeah, good. Thanks, Peter. Good question. And I guess I was thinking about the I guess my question at the beginning about where to access that soil pit data and using the soil map app or looking at another GIS, I guess, is just to be able to provide that background information if you are going out to do a soil pit. So I guess if the guys participants had thought, yes, I do want to do a soil pit, and I want to do it at this particular farm, having a look to see if a soil pit analysis, by the soil scientist has been done, so that they can actually refer to it, I suppose, or give themselves a bit of background information about what they might find and to support them to do the description. Would that be a fair call, Richard? Or
yeah, look, I think DPIRD is still the best port of call for that information. There's obviously not as many people around in WA in DPIRD with that expertise as there used to be, but as I say, people like Tim and Steve Davies at Geraldton, and they have a wealth of knowledge and a really good point of reference for and if you're working in a particular district or region, probably in most cases the type of profiles that you encounter boil down to half a dozen of the major ones. So you just need to become familiarized with those. If you move to a different area, you'll have to learn some different soil profile types.
yeah, and I guess at least if you know where to go to look at what's already been done, even with help with planning trials or locating trials, and before you even start talking to the landholders,
Yeah,
do that bit of groundwork.
and look, consultants obviously have quite a lot of knowledge as well. Whether I guess if you know a particular consultant, they're probably willing to share and divulge that information, but they obviously prefer to reserve that as much as they can for their clients. And I think that many of the consultants probably tend to focus on the chemical properties from soil testing. Yeah.
The other things that I've thought about with doing soil pits is, where they're located in the paddock, and considering what time of day you might be in the paddock. So considering the way that it might be
the orientation
face might be, yes, if it's a north facing soil pit face, or so that if you've got a morning field day, you might want it to face east so that you've got the sun on it. Or in the west in the afternoon.
Yep, indeed. That's just a simple thing, but makes a big difference to the effectiveness of what you present on the day. And that backhoe pit that I showed earlier, the advantage of that type of backhoe pit rather than a sort of box type backhoe pit is you do get a little bit more of a lateral picture into the soil, so that you can get a bit better idea of some of the natural variability in the soil profile that an auger hole doesn't produce, and even a pit, depending on where you dug the hole, you might get a variation on the profile that's a bit atypical.
Yeah.
But I guess you'd be talking to farmers about location as well, and they do enough digging around that they'd probably have a pretty good idea of whether the profile exposed is the typical one or the usual one, or whether it's a little bit of an outlier.
Yeah, and sometimes, and perhaps some of the grower groups do this already, but in preparation for a soil field day, often we've sown or just scattered some different types of crops, seeds, you know, so that you could have canola growing next to wheat, next to lentils, next to peas, or some pasture varieties as well, so that when you dig the pit, you can see the rooting depth of all those different crop types at that time. So you might actually see wheat growing deeper than barley for whatever reason, you know, or if there's a constraint in those.
Yeah, just I haven't actually seen that, but that seems like a good idea. I guess you just need to make sure you talk to the guy who's spraying the herbicide to make sure they don't wipe it out. And of course, you've got to plan ahead.
Yeah, that's right. Easy to do on a dedicated field trial site where you can say, well, this is where the soil pit's going to go. Not so easy if you're talking to a farmer at the beginning of the year, at the beginning of the season or whatever, and say, can you please be careful of this? So yeah, it does take a bit of planning, but few ideas anyway. So
Felicity, I was just going to ask, with the soil constraints project we did a couple of years ago, we were going around digging up legumes for nodulation, and just digging a square, 30 centimetres deep or 30 by 30 by 30, and dropping that on the ground, and seeing how it broke apart, you know, when you drop it. Just wondering if that was a worthwhile thing to do. We found it with the sort of sandy soils on the coast, they were quite often compacted, and they took about 10 drops and actual throws onto the ground to break up, whereas some of the more clayey soils or better structured soils would quite often just, shatter, and that 10 to 20, 30 centimetre layer would sort of break off easily, and you'd just be left with the roots and the topsoil that the roots were hanging on to. Don't know if you've got any comments, Richard.
Yeah, no, I think that's a good practical way of seeing how the soil material behaves. And of course, a large part of your area is high rainfall and pastures where you've got reasonably good development of structure. As you go into the drier parts of the eastern wheat belt and sands, then there's next to no structure at all. So it'll all just collapse.
Well, that's what I was going to ask, was just with the sand, you was talking about apedal and massive versus singular grain. Sometimes that sand is, I don't know, I assume it's just compaction, that sometimes it's almost feels like it's massive. And would that be a classification that you could use for that type of situation?
Yeah, Jeremy Lemon and Steve Davies, when they go out to do these exercises with growers and the like on profile diagnosis, they would generally either take a screwdriver or a knife out and just look at how easy it is to push that into the different layers. So you just start at the surface, and every 5 centimetres or so, you just push it in. And if there are compacted layers, it's quite pronounced effect on how easy it is to push the screwdriver or the knife in. And look, and often growers, when they see that, they're sort of quite shocked, because they sort of didn't realise just how pronounced that compaction effect was in the soil and where it was in the profile.
Great, thanks, Peter. Thanks again, Richard. You've been a wealth of knowledge and a really great support for the guys over there, and a support for me. You've always been willing to present and share your knowledge over the last couple of years. So, and yeah, under these sort of circumstances where we can't get together, but yeah, you've always given a great engaging presentation and sharing your resources. It's been greatly appreciated by myself, and I'm sure the group at large. So thanks again for your time. And yeah, I guess this is the last one. So like I said at the beginning, I'll be sending out another survey just to wrap up the project. Hopefully there could be an opportunity for us to continue. So I'll put that at the end of the survey. So there'll just be a box, or if you want to make some comments about how you might like to continue to be involved in whatever capacity that might be, just staying connected or on a mailing list or attending, being invited along to events, then we'll certainly keep that opportunity open, hopefully, going forward. So yeah, I just wanted to say thanks to all of you for being involved and coming together and forming this community of practice for Western Australia. Like I said, hopefully we can keep it going and keep connected and share information one way or another. I'll continue to populate the Extension Oz platform. So if you have any other resources that you'd like to pop on that, then we'll use that as an information sharing platform for as long as we can. And yeah, I just thank you all for turning up and engaging and asking questions and participating. It's been really great, and I really hope that you've got as much out of it as we've been able to. And it's just been so unfortunate that we've been in this situation where we haven't really been able to make the most of what we wanted to do. But I think that we've perhaps done the best we can under the circumstances, and hopefully as things free up, we'll be able to get together in person a bit more and do that networking that we were hoping that we could do. So thanks all again for coming along, and yeah, we'll be in touch, and if there's any feedback you'd like to give, then please do. And yeah, I wish you all the best going forward. Stay well and stay safe.
Thank you very much. My pleasure to be involved. Stay in touch.
Yeah, for sure. Thanks, Richard.
Okay.
Thanks, everyone.
Bye, everyone.
Bye.